Okay guys, this is Unit 2, Guided Notes number 2 on subatomic particles. You're really going to need a periodic table today, and as well as maybe a calculator to help you with some pretty simple math as we go through how to calculate the number of subatomic particles in an atom of an element. So when you look at your periodic table, what you're going to see is a symbol that looks like this with numbers and symbols and the name of the element. So I want to point out to you what these numbers actually mean. This number here, 8 at the top, this is the atomic number of an element. And this is the number that really identifies the element. It is the number that is really equal to the number of protons that are in a particular element. And that's the identifying characteristic. Oxygen has 8 protons, whereas something like hydrogen only has 1 proton. So that's going to be the biggest key difference when you're looking at any element on the periodic table. That's what you're going to see is really how we can tell one from another. So then, of course, you have the actual symbol of the element. This is either a 1-letter, 2-letter, or sometimes even 3 letters to help us identify. It's telling us always the name of the element that's there. And then the number that's on the bottom, for instance here, the 16, this is what we call the mass number. Okay, sometimes it will also be called the atomic mass, but for just to keep ourselves from getting confused between atomic number and atomic mass, we'll call it the mass number in class more often. And the mass number is really where the weight of the element is. The mass number of an element is always going to be equal to the number of protons that you have plus the number of neutrons that you have. All right, so we're going to do some pretty simple math with all of that. So again, atomic number will always be telling you how many protons you have, and then mass number is your protons plus your neutrons. So we're going to have to be able to add that up. So we have a chart here, and what you're going to be looking for as you work your way through this chart are a few things. You're going to be looking for the number of each of these subatomic particles, the protons, the neutrons, and the electrons. You're going to look at the charge, the mass number, and you're going to go through and find the symbol. So for instance, the name of this element is nitrogen. As you search through the periodic table, you've got all of those things there. Nitrogen's symbol is N, so that may help you to find that element a little bit faster. Nitrogen, when you're looking at the periodic table, has an atomic number of 7. That's the number of protons. So that's what you want to think about. Protons, remember, is always going to be equal to that atomic number. So as you're looking your way through. And remember that this mass number, the mass number will be the protons plus the neutrons. So when you're thinking about the equation for that reaction. So if I know my mass number is 14, well, what is 14 equal to? 14 is equal to the number of protons that I have plus the number of neutrons that I have. So what I'm thinking here is, what do I have to add to 7 protons to get a total mass number of 14? And that would be 7. The last piece of this to think about is the charge. If something has a 0 charge, whenever it has a 0 charge, what that means is that the number of protons, okay, which are positively charged, is equal to the number of electrons, which is a negative charge. Okay, so we'll write the charges up here. Again, protons have a positive charge, neutrons are going to be neutral, they don't have a charge, and electrons have a negative charge. So when we talk about mass, or excuse me, when we talk about the charge, if it's 0, the proton number is equal to the electron number. So if we have 7 protons, we're going to have 7 electrons because they would cancel each other out and give us a charge of 0. All right, so looking at the next example, we have argon. Argon, we look for, the symbol is AR. Okay, notice it's always going to be a capital letter and then a lowercase letter as we write those symbols out, and you want to be careful to write them correctly. Argon, when we're looking, we're going to find AR on the periodic table. Argon's atomic number is 18, so that means it has 18 protons. We see that our charge is 0. If a charge is 0, we know the protons and the electrons are going to be the same. So we have 18 protons and 18 electrons. We need to figure out the number of neutrons. So again, we're going to think about what we have. We know the total for protons and neutrons is 40. So we can take 40 and subtract the number of protons to give us the number of neutrons that are there, okay, which would be 22. All right, and the next example is calcium. For the first time, we have a charge on this element, so we're going to work our way through something that has a charge. Calcium symbol is Ca. All right. It's got a mass number of 40, and you may notice that some of these numbers are not the same as what you see on your periodic table, and that's fine. We're going to go with what's on the chart that's here, and the only number that we're really going to ever get from the periodic table anyway is our atomic number. So the atomic number of calcium is 20. Okay. And so let's go ahead and figure out our number of neutrons. Well, what do we know? We know that this number plus this number has to equal 40. Okay, so 20 plus blank is equal to 40. That's essentially what we're figuring out. So we can sort of do some simple math there. 20 plus 20 is equal to 40. Now, when there is a charge on an element, or we would actually call it an ion if it has a charge. Okay, so the ion just means that it has a charge, be that positive or negative. If it's an ion, it's going to have a charge. Well, what we need to think about is this. If the charge is positive, the positive means that we have more protons, okay, than electrons. And how many more protons do we have? Well, this time we have 2 more protons because we have a +2 charge. So we have 2 more protons than electrons. Well, this number 20 cannot change. Okay, this number can't change. That's our atomic number. It's got to stay the same, because if we change that atomic number, we're not dealing with calcium anymore. So we have 20 protons. We need to have 2 more protons than electrons, so we can only have 18 electrons in order to get that. So a lot of times what my students notice is that we take this atomic number, the number of protons, and we sort of do the opposite of what the charge says. If the charge is +2, we're going to take that proton number and we're going to subtract 2 to get the number of electrons. And so let's use that same basic idea, and let's work our way through this next example, which is bromine. Okay, bromine is Br. So when you look up and find bromine, bromine's atomic number is 35. Okay, so again, let's quickly figure out what our number of neutrons is based on that. So 80 minus 35 would give us 45. So again, or another way to say that is 45 plus 35 is equal to 80. So we know we have the right number of neutrons there. Now we have to figure out our number of electrons using that charge. So again, remember, the number of protons can't be adjusted to do that. We have to think about this. If our charge is negative, now our charge is negative, that means that we have more negative charges. So that means that we have more electrons than we have protons. And how many more electrons do we have this time? Well, we have 1 more electron because we have a charge of -1. So instead of 35 electrons, we need to have 1 more. We need to have 36 electrons in this case. All right. So as we go through, you're just continuing to practice this process, and repetition is really what chemistry is all about, understanding what you have. Sodium, for the first time, our symbol doesn't look the same. Sometimes these symbols are made based on the actual Latin of the name, and so we don't always recognize them. But sodium is Na. Sodium's mass is 23 in this case, and this is an atomic number of 11. So again, let's figure out what we need to know about the number of neutrons. So again, we're thinking, what do I have to add to 11 to get a total of 23? Okay? Or you say 23 minus 11 would give us a number of neutrons of 12. Okay? I know with electrons, again, positive charge. Positive charge, remember, means that we're going to have more protons. We have 2 more protons, so essentially we can say 11 minus 2 means that we have 9 electrons in this case. Okay, the next example is chlorine. Chlorine is Cl, and with chlorine there is a mass number of 35. When you look it up on the periodic table, chlorine's atomic number is 17. So again, 17 plus blank is equal to 35. Or another way to say that again is 35 minus 17 is 18, and that gives us our number of neutrons. Now we have to figure out our number of electrons, and this time we need to have more electrons than protons. So we know we have 17 protons. We need 2 more electrons than that. So we're going to do 17 plus 2, and that is a total of 19 electrons. Okay, the last one of these examples, and then you're going to work to finish this off on your own for a few minutes. Oxygen. Symbol is O. We have a mass of 16, a charge of -2. We go look on the periodic table. Oxygen's atomic number is 8. Okay. So what do we have to think? What do we add to 8 to get 16? Well, that's another 8. And then this time, if it's a negative charge, we need to have more electrons. We need 2 more electrons than protons. So 8 plus 2 is a total of 10 for our number of electrons. So what I would like to see you do is pause here and work your way through the bottom half of this chart. And then as a class, once this is pulled up, you can go back through and you can check your answers with each other and with Miss Vaught, who's here as your substitute, and see if you're getting these right or wrong. So stop here for a few minutes, finish that up, and then when you come back to the video, we'll be working on the back side of that. So I'm going to progress through the slides onto the back side. And the back side looks similar to what the front side looks like. It's just that you now have a mixture of information. So you've got to sort of figure out what you're looking for. So if you have the symbol but not the name, you go to the periodic table, you find the symbol Si, and that should tell you that your element is silicon. All right. Once we know the name of the element, we can find our atomic number. The atomic number of silicon is 14. So again, remember that atomic number is always the number of protons that we're going to have. Now we know our mass number and we know our protons, so we can figure out the number of neutrons that we have. So we think 28 minus 14, well, what does that give us? That gives us 14. So we have to have 14 neutrons and 14 protons to give us a mass number of 28, because remember, protons plus neutrons is your mass number. Now, this is the first time that you have to figure out the charge of the element yourself. So again, when we are considering the charge, you're going to be considering the number of protons you have and the number of electrons you have. And when we compare those two numbers, you see that we have 14 protons and 18 electrons. Well, that means that we have 4 more electrons than protons. So our difference is 4. Is that a positive difference or a negative difference? Well, we have more electrons, so that's a difference of -4 as our charge. Okay, aluminum. So we've got the name of the element. What we're going to do is then find the symbol. Aluminum symbol is Al. In this case, the only thing that we should ever really pull from the periodic table is either the name, the symbol, or the atomic number. So let's find the atomic number of aluminum, which is 13. And now what we can do is fill in the rest of this chart. So to get our mass number, we're going to add 13 protons and 14 neutrons, and that gives us a mass number of 27. And then again, what we're going to do is compare our protons to our electrons. And now what do we have? We have 13 protons and we have 10 electrons. So we know we have more positive charges than negative charges. So go ahead and put that positive sign there. There's more positives than negatives. How many more positives are there? Well, there's 3 more positives, so the charge is +3. Okay, in this next case, all we're given is the number of protons, neutrons, and electrons. So we don't know the name, we don't know the symbol. The thing that we do know that will help us is the atomic number. So we go and find the element that has atomic number 15. And atomic number 15 is phosphorus. All right, and the symbol of that is P. That's all we can pull from the periodic table. So again, now we're going to add our protons and our neutrons together. 15 plus 16 is a total of 31. That's our mass number. And then how do we figure out our charge? We compare protons and we compare electrons. I have more electrons, So I know my charge is negative. The difference between the protons and the electrons is 3, so that's a charge of -3 in this case. Okay, last example, and then again, you should be able to work your way through and finish this chart off and check your answers with each other and with Miss Ball. Our atomic number is 33, so we're going to find element number 33. That is arsenic. Arsenic symbol is AS. Right. We know that we have a charge of +3, so we have 3 more protons than electrons. So 33 subtract 3 is a total of 30 electrons, and then 75 minus the 33 will give us a total of 42 for the number of neutrons that are there. Alright, so practice this. Again, stop the video here, go through, finish the rest of those examples off on your own, and be sure that you're checking your examples. I would encourage you guys to do that as a class. Give you, a few minutes and then run yourself through these examples together.